Object-oriented methodology. In this video, we are going to see about object-oriented methodology. The object-oriented methodology of building system takes the object as a basis. For this, first the system to be developed is observed and analyzed, and the requirements are defined as in any other methods of system development. Once this is done, the objects in the required system are identified. For example, in case of a banking system, a customer is an object, a checkbook is an object, and even an account is an object. Most of the object-oriented methodologies originated in the late 1990s following the rapid expansion of OO languages in the 1980s. We will consider three of the most influential object modeling technique, that is OMT, object process methodology, that is OPM, rational unified process, that is RUP, object modeling techniques, that is OMT. OMT, Object Modeling Techniques, was one of the first OO methodologies and was introduced by Rombach in 1991. It uses three different models that are combined in a way that is analogous to the older structure methodologies, for example, Jordan DeMarco. Object Process Methodology, that is OPM. OPM is a second generation methodology and was first introduced in 1995. OPM has only one diagram, the Object Process Diagram, that is OPD, for modeling the structure, function, and behavior of the system. Every OPD can be described in text form using the Object Process Language, that is OPL, a constrained natural language. OPM has a strong emphasis on modeling but has a weaker emphasis on process and consists of only three main processes: initiating, determining the high-level requirements, the scope of the system, and the resources that will be required. It consists of three sub-processes: identifying, conceiving, initializing. Rational Unified Process, RUP. RUP was developed at Rational Corporation in 1998 by the same people that developed UML. Although it is said to have a lifecycle, RUP has an evolutionary or iterative approach rather than the linear or waterfall approach of earlier methodologies, which is shown in the below figure. The RUP lifecycle. Project Management Plan and Issues for Web-Based Project. In this video, we are going to see about Project Management Plan and Issues for Web-Based Project. Project Summary. ACIC is a USA-based investment firm. This application has two components. First, a brokerage account opening application on ACIC's website, which will allow any internet user to open a brokerage account with ACIC. Second, an account opening and maintenance application, which is primarily for ACIC's representatives to open accounts for the applications received in paper format. This is an intranet application. Project code, project name, customer, project leader, that is PL, configuration controller, that is CC, business manager, that is BM, backup PL, backup CC, project types, platform, number of phases, project start date, project end date, total estimated revenue, project and customer contact personnel, project scope, to provide an effective, efficient means of account maintenance activities, to allow reps to access information, provide a complete picture to the client rep for account status, valuation, order status, and trade activity, increase the intelligence of the update process, provide an interface that is able to display required account history elements, provide capability to close and reactivate an account. Infosys objectives: strengthen relationship with ACIC by delivering high-quality software on time, become preferred vendor by developing expertise on their products and system, commitments made to the customer, milestone date, milestones, deliverables. Other commitments. Commitment: project planning using object-oriented methodology. In this video, we are going to see about project planning using object-oriented methodology. Project processes. Standard process followed. The standard development process of Infosys will be followed. However, it will be enhanced with Rational Unified Process Methodology (RUP) as it is a commitment. The development process will be tailored to match the RUP. Tailoring notes. Deviations from standard process: added or modified or deleted. Reasons for deviation: only those use cases that are going to be taken up in a particular iteration will be elaborated at that point of time. Modified, as iteration-based development is being done. Development of logical object model will be done incrementally in the first few iterations. Modified, conformance to RUP methodology. Development of physical object model will be done incrementally in the first few iterations. Modified, conformance to RUP methodology. Physical database design may be refined in later iterations. Modified, conformance to RUP methodology. Development of unit test plan will be done in each iteration. Modified, as iterative approach is being used. Logging of defects will be iteration-wise. Modified, as iterative approach is being used. Requirement traceability will be done through the Requisite Pro tool. Modified, conformance to RUP methodology. No vision document and business case, as we started with the scope document which serves the same purpose. Modified, deviation from RUP. Estimated size and effort. Estimation criteria. Program or function use case. Criteria. Simple use case, 3 or fewer transactions. Medium use case, 4 to 7 transactions. Complex use case, greater than 7 transactions. Use case number. Description. Complexity. Use case 1, screen navigation, complex. Use case 2, update profile details, medium. Use case 3, add address, medium. Use case 4, update address, complex. Use case 5, delete address, complex. Use case 6, add telephone number, medium. Use case 7, update telephone number, complex. Use case 8, delete telephone number, complex. Use case 9, add email, medium. Use case 10, update email, medium. Use case 11, delete email, medium. Use case 12, Update employment details of a party, medium. Use case 13, update financial details of a party, medium. Use case 14, update details of an account, medium. Use case 15, maintain activities of an account, complex. Use case 16, maintain memos of an account, simple. Use case 17, view history of party details, complex. Use case 18, view history of account details, complex. Use case 19, view history of option level and service options, simple. Use case 20, view history of activities and memos, simple. Use case 21, view history of roles, complex. Use case 22, view account details, simple. Use case 23, view holdings of an account, complex. Use case 24, view pending orders of an account, complex. Use case 25, close or reactivate account, simple. Use case 26, intelligent update to business partner of ACIC, complex. Estimated build effort, program or function. Program or function effort based on data from earlier project. Number of units. Total build effort in person days. Total 146. Phase-wise effort estimate. Activity of phase. Person days. Percentage of total effort. Estimated effort 501, 100%. Effort estimated by iterations. Percentage. Percentage of total effort. Total estimated effort 501%, 100%. Schedule. Specified as milestones in the section on commitments to the customer. People. People by role. Role. Required. Date. Total 9, actually 8.5. 14th August 2000. People by skill and experience. Area. Total 0 to 12 months experience. Total 9, 7, 2. People requirement plan. Month. Offshore. On-site. Total. Development environment. Hardware. Software. NT server. WinNT. Mainframe. DB2. Intel PC. Visual Edge for Java. Java. WinNT. Hardware and software resources required. Item description. Required. Date. Tools. Tools list. Tools to be developed in the project. None. In-house tools to be used in the project. None. Training plan. Training area. Duration. Waiver criteria. Technical. Java language 7 days if already trained. Visual Edge for Java 3 days exposed as part of initial training. Java applets 4 hours if already trained. Java Swing 4 hours if already trained. Persistence Builder 4 hours if already trained. Rational Rows and Requisite Pro 8 hours mandatory. OOAD on day if already trained. Business Domain. System Appreciation 7 days if already trained. Process Related. Quality System 3 hours if already trained. Configuration Management 2 hours if already trained for CC for others on the job training. Group Review 4 hours if already trained. Defect Prevention 4.5 hours mandatory. SPC Tool 4.5 hours if already trained. RUP Methodology 2 hours mandatory. Quality Plan. Quality Goal. Project Quality Goals. Goals. Value. Basis for setting goals. Organization-wide norms. Estimates of defects to be detected. Review or testing stage. estimated number of defects to be detected, percentage of defects to be detected, basis for estimation. Strategy for meeting quality goals. Strategy, expected benefits. Do defect prevention using the standard defect prevention guidelines and process. Use standards developed in Synergy for coding. 10 to 20% reduction in defect injection rate and about 2% improvement in productivity. Group review of program specs for first few or logically complex use cases. Group review of design docs or first time generated code by project leader, developer, and one consultant. Improvement in quality as overall defect removal efficiency will improve. Some benefits in productivity as defects will be detected early. Introduction of RUP methodology and implementing the project in iterations. Milestone analysis and defect prevention exercise will be done after each iteration. Approximately 5% reduction in defect injection rate and 1% improvement in overall productivity. Reviews. Review point, review item, type of review. End of project planning. Project plan, DCS setup, project schedule. Group review, SQA review, SQA review. End of project planning, CM plan, group review. End of 90% of requirements. This should be at the end of first elaboration iteration, business analysis and requirements specification document, use case catalog, group review. End of 90% design. This should be at the end of second elaboration iteration, design document, object model, group review. Beginning of each iteration, iteration plans, 1% review. End of detailed design, complex of first time generated program specs inclusive of test cases, interactive diagrams, group review. After coding for first few programs, code, group review. After self-testing of a process, code, 1% review. End of unit test plan, 1% review. Beginning of integration test plan, group review. Risk management plan. Risks, probability, impact, risk exposure, mitigation plan. Support from database architect and the database administrator of the customer, 0.5, 8, 4. Plan carefully for the time required for each of these groups and give enough prior notice. On-site coordinator to work closely with these groups. As RUP is being used for the first time, the understanding of the team may not be complete. 0.9, 3, 2.7. Work closely with experts in the R&D lab of Infosys. Keep the customer in the loop throughout the project and escalate for any schedule or effort deviations. Train the team on RUP methodology. Personnel attrition. Team members might leave at short notice. 0.3, 7, 2.1. Assign tasks so that more than one person is aware of the units or use cases in the project. Working with customers' mainframe DB2 over the link may not be as efficient as it is expected. 0.1, 8, 0.8. Do extra code reviews, disk checking, etc. to minimize the reliance on link. Escalate as soon as the link goes down. Project tracking using embedded system. In this video, we are going to see about project tracking using embedded system. Measurement plan. Metrics to be collected. Unit of measurement. Tools used. Size. LOC, FP, S or M or C count line counters. Effort percentage WAR. Defects, number of defects Bugs Bunny. Schedule, elapsed time MSP. Task tracking. activity, procedure. Task scheduling. The PL schedules tasks using MS Project. Refinement and rescheduling will be done when necessary. Task assignment. The last schedule is made available to the team members. Once the schedule is uploaded to WAR-MSP system, the task will show in their respective WARs. Task status tracking. Task tracking is done daily. Project meeting. Once in a week. Causal analysis meeting. After every iteration. Issues tracking. Issues types. Where logged. Who can log. Who reviews when. When escalated. On-site issues. Issue tracker.xls. Any member of the project. PL daily 2 days. Customer issues. Issues log.xls. On-site team PL daily 2 days. Business manager issues. Weekly status report. BM PL weekly 5 days. Issues with support services. Request tracker. Any team member. Support services daily 2 days. Customer feedback. Item. A logging and tracking process. Customer feedback. The AM or PL gets the customer feedback. The BM files it. Customer complaints. Customer complaints received will be entered and tracked using customercomplaints.xls. Quality tracking. Quality activity. Action. Defect tracking. Use DCS for logging defects and tracking them to closure. Reviews. Requirements. High-level design. Detailed design. Check against project goals in quality plan. Code review. Check against limits for each program through SPC tool. Independent unit testing. Check against limits for each program through SPC tool. Integration testing or system testing. Check against project goals in quality plan. Review by senior management BM. Item for review. Frequency of review. Schedule. Every version change. Project plan. When some significant changes are made. Milestone report. End of milestones. Status reporting. Report to. Frequency. Business manager. Weekly on Monday by email. Customer. Weekly on Monday. Deviation limits at milestones. Actual versus estimate of. For the first 5 milestones. For the rest of the milestones. Effort 10%, 5%. Schedule 10%, 5%. Defects 20%, 20%. Report to the customer. Milestones reports and weekly status reports. Issues requiring clarifications. Escalation if any. Report to the BM. Customer feedback. Milestones and weekly status reports. Issues requiring clarifications or attention. Escalation if any. Number of requirement changes and estimated effort for them. Major changes in plan. Escalation procedures. Escalate where. Threshold period. Name of the person. Designation of the person. At ACIC 3 days. XXXX Project Manager. At Infosys 3 days. XXXX Account Manager. at Infosys, 3 days, XXXX Business Manager. Project Team. In this video, we are going to see about Project Team. Project Organization, Project Team, Initials, Responsibility, Start Date, Expected End Date. PP, Project Manager, 4th April 2000, 3rd November 2000. KP, On-Site Coordinator, 4th April 2000, 3rd November 2000. BS, Module Leader, Backup Project Lead, 15th May 2000, 3rd November 2000. SP, Configuration Controller, 22nd May 2000, 13th November 2000. DD, Developer, 22nd May 2000, 29th September 2000. HP, Developer Backup Configuration Controller, 22nd May 2000, 29th September 2000. NA, Developer, 17th July 2000, 3rd November 2000. SH, Developer, 1st August 2000, 15th September 2000. AL, Developer, 14th August 2000, 31st August 2000. JP, Developer, 1st September 2000, 22nd September 2000. SDS, Account Manager, 4th April 2000, 3rd November 2000. SB, SQA, 15th May 2000, 3rd November 2000. Roles and Responsibilities. Role, Responsibilities. Business Manager, BM, resolve escalated issues, review project status, participate in critical technical reviews. Customer, review design, resolve escalated issues, acceptance test planning and testing. Account Manager, AM, customer satisfaction, business growth, project financial plan, interfacing with sales and marketing, training related issues, employee related issues. Project Manager, PM, project planning and scheduling, design, customer interaction, reviews, testing, reporting, task assignment and tracking, interact with software quality advisor from SCPG, ensure delivery as per contract, interface with other departments as per need, ensure project members are adequately trained. Module Leader, ML, design, development, testing, reporting. Defect Prevention Team, DP Team, spread awareness in the team on defects and their prevention, analyze defect data, identify methods to reduce defect injection. Developer, DV, detailed design for use cases, development, unit testing and integration testing. Configuration Controller, CC, prepare the CM plan, manage the configuration as per the CM plan. Software Quality Advisor, SQA from the SCPG, process consultancy, quality assurance audits, install measurement tools and train project personnel, participate in reviews of project plan and process as necessary. On-site coordinator, resolve any issues from customer or offshore, support during development. Embedded System. In this video, we are going to see about Embedded System. An embedded system is a specialized computer system that is usually integrated as a part of a larger system. An embedded system consists of a combination of hardware and software components to form a computational engine that will perform a specific function. Unlike desktop systems, which are designed to perform a general function, embedded systems are constrained in their application. Embedded systems often perform in reactive and time-constrained environments. A rough partitioning of an embedded system consists of the hardware, which provides the performance necessary for the application, and the software, which provides a majority of the features and flexibility in the system. A typical embedded system is shown in the figure. Typical embedded system components: processor core. The heart of the embedded system is the processor core. This can range from a simple, inexpensive 8-bit microcontroller to a more complex 32 or 64-bit microprocessor, or even multiple processors. Analog I/O. Digital or analog and analog or digital converters are used to get data from the environment and back out to the environment. Sensors and actuators. Sensors are used to sense analog information from the environment. Actuators are used to control the environment in some way. User interfaces. These interfaces may be as simple as a flashing LED or as complex as a sophisticated cell phone digital still camera interface. Application-specific gates. Hardware acceleration such as ASIC or FPGA is used for accelerating specific function in the application that have high performance requirements. Software. Software is a significant part of embedded system development. Embedded software is usually optimized in some way: performance, memory, or power. Memory. Memory is an important part of an embedded system, and embedded applications can run out of either RAM or ROM depending on the application. Emulation and diagnostics. Many embedded systems are hard to see or get to. There needs to be a way to interface to embedded systems to debug them. Diagnostic ports such as JTAG, that is Joint Test Action Group, are used to debug embedded systems.